Lead screw end machining entails any kind of extra modification on either end of the lead screw to fit the needs of a customer's application. As you may already know, lead screws are a convenient and cost-effective device for converting rotary motion into linear motion. Depending on the application requirements, a lead screw will typically require a bearing on one or both ends to retain the axial position of the lead screw but still allow rotation. For lead screws with long lengths or high rotational speed requirements, bearings may be needed on both ends of the lead screw. Any bearing arrangement will require end machining on the lead screw. We have found that the majority of lead screw applications do involve some sort of modification like this from what we consider standard product on one or both ends due to the sheer variety of ways lead screws are used in the field. This is why most of the lead screws we ship at Thomson feature some kind of end machining. To better understand how end machining can differ, let's first briefly discuss some important attributes. The most important of these is the journal, which is the smooth diameter at the end of a lead screw and used as a mounting surface for bearings, couplings, or other components. It is this smooth surface that is modified when we refer to end machining. There are many different end machining combinations for lead screws, but a common type is fixed or simple machining. We have three examples of fixed simple machining with additional millwork. The fixed end includes a bearing journal diameter, a lock nut thread, and a drive shaft. The lock nut thread allows a lock nut to secure the inner race of the preloaded bearing against the lead screw shoulder. With certain bearing designs, the lock nut can actually set the preload of the bearings. It is important to have sufficient material below the lead screw minor diameter to properly seat the bearing inner race, so please refer to the Thomson catalog for bearing size recommendations for each lead screw size. The simple end has a bearing journal diameter with a snap ring groove to retain a radial bearing, or in some cases, a simple bushing. All three of these lead screw examples show optional millwork that Thomson provides. The first example shows a fixed end with a drive shaft and keyway. The keyway on the drive shaft provides anti-rotation and is often used with a motor coupler or a belt pulley. Some coupler and pulley designs utilize a set screw for anti-rotation, so flats may be required on the drive shaft. Other designs utilize a cross hole on the drive shaft for anti-rotation. Many designs require position adjustments during installation, and this can be achieved with an external hex or a slot on one of the machined ends. These features can also be used to provide anti-rotation when tightening a lock nut to the appropriate torque setting. As previously mentioned, the end machining varieties shown here cover the common types that are used and ordered. However, Thomson engineers are able to create custom designs in conjunction with collaborative discussions with the customer's engineering team. To learn more about Thomson lead screws and our end machining capabilities, visit thomsonlinear.com or contact our experienced customer support team.